We jumped over some questions at the end of the last video, so we'll skip back to those and answer them because they're classic exam type problems. Okay, so the first question, find the coordinates of the points on the graph y equals x squared from which the tangent line to the graph passes through the point 3, negative 7. So essentially what's happening with this one is we've got the basic parabola y equals x squared, and we want the situations when the tangent to this curve goes through the point 3, negative 7. So essentially we're going to get 2 points, one like this, so the tangent will be to the curve there, and one over here. So this is why it says coordinates of the points, because there's two situations where it'll go through. Right, there's a typical way in which we do these problems. So first of all, let's select a point on the curve where this is going to happen, i.e. when's it going to happen. We're going to let that point be point A. Could be point P, could be point C, it doesn't really matter. I've just chosen A because it's the first letter in the alphabet. And then what we'll do is we'll put A squared, because that is the Y value at that point. So that's the value of X and the value for Y in which we want the point. Okay, now it's also going to include the point 3, negative 7. So our tangent is going to go through A and A squared and 3 and negative 7. Now what's the gradient going to be for these tangents? Right, well let's have a look. So I'm going to say that let y equal f of x, and I'm going to find f dash x, the gradient function, and I'm going to note that that is 2x. Now with the gradient function, what I'm going to ask the gradient function is when do you have or what is your gradient at point A? I'm going to say f dash A, which is 2a. And now I've actually got all the ingredients I need to solve this problem. Excuse me. So what I do is I write down my formula for the equation of a straight line, which is y take y1 equals mx take x1. All right, so let's call this x1 and y1 and x2 and y2. And let's note that our gradient is 2a. So let's fill in what we know. So I'm going to say that this is negative 7 take a squared equals m, which is the gradient, 2a. And we've got, what do we do? This, so that's going to be 3 take a. All right, let's expand this out. Take away 2a squared. All right, what I'm going to do is add 2a squared and subtract 6a squared from the right-hand side. So that's going to leave me with a squared, take 6a, take 7 equals 0. Now let's factorize this. A, 7 and 1. This is going to be the negative. A takes 7, a plus 1 equals 0. A equals 7, a equals negative 1. Right, so let's go to our acceptable values of a, and what we're going to do is pop them into this. This is the point where the tangent passes through 3, negative 7. So what we'll do is we'll sub a in. So we've got a is equal to 7, a squared is 49, a is equal to negative 1, and negative 1 squared is 1. So let's check that solution via a graph. So we've got y equals x squared. Now, one of the points where the gradient of the tangent runs through 3, negative 7 is at, where is it? Negative 1, 1. So let's pop it in. So it's there. So what I'll do is I'll get GeoGebra to draw a tangent. Select point and function, and it draws the tangent. Now, I'll also put the point 3, negative 7 in, and lo and behold, the tangent runs through there. Now, the other one was at 7 and 49, so I'll just pop that point in as well. So that's all the way up there. That's a fair way up there. All right, but I bet when I draw a tangent at that point there, or at that point there to this line here, Lo and behold, it also goes through the point 3, -7. So the graph seems to suggest, or is suggesting that we're correct. All right, similar problem here. The tangent to the curve with the equation y equals x cubed plus x at the point here passes through this point. So they've actually given us the point here rather than us having to sub p into or a into the function itself. So find the values of a. We don't need to actually find the coordinates, just the values of a. Note that it's value or values. Right, so first things first, what we'll do is note that one point is a cubed plus a, the other point is 1, comma 1. Now what we'll do is get our gradient at point A, that is the point on the curve where it will allow it to go through 1, 1. So we'll go let y equal f of x, noting that f dash x, the gradient function, is 3x squared plus 1. Right, f dash a is 3a squared plus 1. All right, so now we can pop this into our y take y1 equals m x take x1, where this is x and y and x1 and y1. Doesn't really matter which way you label them. All right, so we've got y take y1, so it's a cubed plus a take y1 equals m, which is 3a squared plus 1, x, which is a take 1. All right, so don't forget to put some brackets around that gradient as well. I have done this problem before and forgotten that and spent ages trying to work out why it wasn't working out for me. So don't forget those brackets. All right, we've got a cubed plus a take 1 equals. Now let's expand this binomial or the binomial products. So I've got 3a cubed take away 3a squared plus a take 1. All right, what we'll do is we'll swing these all over to one side. So I've got 2a cubed take away, so this is take away a, so that'll cancel those a's out. Add 1, which will cancel that. So I'm left with 3a squared here. All right, and that's 0. 0 equals a squared. 2a take 3. A is equal to 0. A is equal to 3 on 2. So there's my values of A for which this will happen. A equals 0 and A equals 3 on 2. I don't need to sub those values back in because in this situation, the only thing they ask for is what are the values of A. Right, this one here, determine the equation of the tangent to the curve f of x equals that if the equation of the normal is parallel to the function 9y plus x equals 18. All right, well, if it's parallel to this line here, the equation of the normal, let's put this function into y equals mx plus c form and pull out the gradient of this line. Okay, m of that line is -1 over 9. So the equation of the normal is parallel to this line here. So what we'll do is instead of using the normal though, what we're going to do is we're going to derive this and ask it when its tangent will be equal to this particular gradient. And that will then allow us to flick it over to the normal. So I'll explain. M1, M2. So remember, if this is the gradient of the normal, okay, what we'll do is get the gradient of the tangent, which will do the negative reciprocal of that, which is just 9. So then what I'll do is I'll f dash x the function, which is 2x plus 7, and ask it when it will have a gradient of 9. For what value of x will the gradient be 9? And that occurs when x is equal to 1. All right, so when x is equal to 1, the equation of the normal will be parallel to this. So we want to determine the equation of the tangent to the curve here. So we've got when it's going to occur at x is equal to 1 and y is equal to f of 1. We know what the gradient will be, which is m equals 9. So all we need to do to get the equation now is 1 comma. What is f of 1? It is 1 7 is 8. 8 take 2 is 6. So y take y1 equals m, x take x1, that's x1, that's y1. Okay, so let's do y take 6 equals 9, x take 1, y equals 9x take 9 plus 6, y equals 9x take 3. There is my equation. All right, let's just see if we can picture this one on GeoGebra as well and get an idea of what our answer suggests. Okay, so file new. Oops. Yeah, it's not a new one. Right, here we go. So our curve is f of x equals x squared plus 7x take 2. All right, and what we have found out is the point where all the action happens is 1, 6. All right, so where is 1, 6? It's there. All right, now let's get it to draw a tangent there. Oops, missed. There's the tangent. Okay, and what we'll do also is we can't do normals, but what we can do is a perpendicular line. So line perpendicular to this one. There it is. So that's the normal. And then finally, if I graph the linear function, 9y plus x equals 18, what we note is that the normal to this point here is parallel to the equation of this line here. So it checks out. It means that our answer is certainly correct. So 9x take 3 is what it's going to be. So y equals 9x take 3. Where's that? Oops, what did I do there? Okay, oh, that's why I couldn't see it, because it's the same tangent there. Okay, so there we go. Determine the equation of the tangent if the normal is there. That's all done. All right, so last problem. Find the equation of the tangent to this curve here at x is equal to 2. Sure. F dash x equals 3x squared. Take 6x take 6. And let's get its gradient. F dash 2 is equal to 2 squared is 4, 12, take 12, take 6, it's negative 6. And our point is 2 comma f of 2, so we've got 8 squared take 12. Let's just try that. Take 12 plus 8. 16 take 24 is negative 8. All right, so let's get the equation of the tangent. Y take y1 equals m x take x1. Y plus 8 equals negative 6. X take 2. Y equals negative 6x plus 12 take 8. Y equals negative 6x plus 4. All right, the coordinates are the point where the tangent intersects the curve again. Now what we'll do is we'll do this via CAS. So what we'll do is we'll let this, the equation of the tangent, equal the function. So we're going to say, when are you the same? All right, now one of the answers is going to be at x is equal to 2, because that's when the tangent occurs. And we're going to get another intersection somewhere else. Okay, so this one here is asking for the coordinates of the point where the tangent intersects the curve again. So the way we'll do it is we'll say solve negative 6 plus 4 equals, what's my cubic? for x. And we've misfired. So, no, we haven't. No, there's the solution that we knew we were going to get, which is x is equal to 2 and x is equal to -1. All right, now we want the coordinates where this occurs. Okay, so this one is already known to us. That's the tangent, so we know it intersects at the tangent. So all we'll do for this one here is do f of -1, which is going to be -1 cubed is -1. -1 is 1, 1, that's -3, plus 6 plus 8. -4 plus 6 is 2, which is 10. So the coordinate, therefore, is -1, 10, where it intersects the function again on top of the 2, -8. All right, so we finished off the lesson looking at rates of change, and we did 2 problems, and this again was a CAS-based problem. So what we'll do is this question here: a balloon develops a microscopic leak and gradually decreases in volume according to this function here. So what we'll do is we'll actually use our calculator to help us with this one. So let's go define f of x equals, our function is 600 take away 10 x take away 1 over 100 multiplied by x squared. Okay, so for this one here, find the rate of change of volume after 10 seconds. Let's say for argument's sake this is a 2-mark question. Okay, so we need to show a little bit. So we want the rate of change of the volume after 10 seconds. So to do that, what we're going to do is find the derivative function. So because there's no, this isn't in function notation, we'll use Leibniz's notation. So we'll go dv dt equals. Right, now on the calculator, we'll get it to do the diff for us. So we'll get the diff function. That is in calculation diff. F of x is the function that we've got on the calculator. And let's get that in standard form. So it's negative t plus 500 over 50. Don't forget, it should be in terms of t. And then the way we're going to substitute is dv dt with t is equal to 10. That's the notation that I use. And so let's do that on the calculator. What I do is I hit the pipe key, which is with, and then I say x equal 10. Okay, and it's negative 51 over 5. And what is it? Centimeters cubed per second. This is the same thing here. So what we're going to do with this one is sub in 20 to that function. And what we've got here is negative 52 on 5 centimeters cubed per second. So note that with this question, what you want to do with this question here is we're just assuming that this is a 1-mark problem. And what we'll do is not show all our working out here. We can just go straight to the answer. Okay, so the last thing we'll do is for how long could the model be valid? Okay, so what values of t make this true? Okay, so t is an element. Well, we know that it's true from time 0 through to what will be the x-intercept of the problem. So let's go ahead, and what we'll do this time is we'll take the original function, f of x, and let it equal 0 for x. And what that's basically going to do is with the original function, it's going to say, hey, when do you have v equals 0? Okay, well, when is v going to equal 0? So we've got 2 possible values here, a negative and a positive. Interestingly, if I go into decimal and approximate, we'll note that there's 2 solutions here. Okay, that one of the solutions is the positive, one is the negative. So we're going to take the positive solution only and say it's from t equals 0 to 100 root 3 root 31 take away 500 is our solution, up to and including that value. All right, let's do this last problem, which isn't on your notes, so you'll need to annotate your notes to do this one. The volume of petrol left in the tank when the engine is running full throttle on a whippersnipper is modeled by this function. So again, it's good practice to define that function. F of x equals negative x cubed plus 6x squared, take away 12x plus 7. Okay, V is the volume in litres and T is the time in minutes. When is the fuel decreasing at a rate of 10 litres per minute? So I think the first thing we should do is get V dash T, which is easy enough to do by recognition, not needing diff on the calculator. So 3t squared plus 12t, take away 12. And what we're going to do is ask the function when it is decreasing, or ask the gradient function when it has a gradient of, in this case, because it's decreasing at a rate of 10, negative 10. Oops. So let's do this on the calculator. So first of all, I'll diff f of x, duff it. And what I'll do is now solve when the ants, which you get by doing shift and exe to get ants, equals negative 10 for x. Right, and it says that it'll be decreasing at a rate of 10 litres per minute 2 times. Once there and once there. Now, which one do we take? Well, we're talking about t equals, okay? So t equals plus or minus root 30 on 3 plus 2. So plus or minus. So which one do we take? Do we take the negative or do we take the positive? Well, it's good practice to just check the two values. So what we'll do is we'll drop this into decimal mode and actually have a look. And interestingly, okay, if we have a look at the domain where t is an element from 0 to 1, what we'll note here is that this first solution is actually the one we're after. Even though it's got a negative sign out the front of it, it actually is a positive number. Let's go back and note that, but t is an element between 0 and 1, therefore t is equal to negative root 30 on 3 plus 2. All right, so there's your 18B questions, applications of calculus.